The next step is to program the volume control. To do this, we need a logic symbol capable of adjusting the volume up and down and a mute function. Since we know we will be programming an analog value, we will go to the Analog Operations Logic System folder. We'll be using an analog increment with optional feedback. The speed key for this logic symbol is AINCF. You can also click and drag the logic symbol into the volume folder. We will now open the help file to learn about this logic symbol. There is a digital input called up, which increments the value of A out as follows. A out equals A out plus increment on each rising edge of up. The down signal follows the same rule, except it decrements instead of increments. The optional digital mute forces A out to a value specified by mute level for as long as the input is high. When the input goes low, this restores A out to its previous value. The analog output represents the analog value controlled using this logic symbol. There are several parameters. The first is hold time, which sets the number of seconds that the up or down inputs must remain high before A out will auto-adjust. This means how long the user needs to hold the up or down before a change in value happens. The repeat time parameter sets the value of seconds that A out will auto-adjust. The repeat time takes effect once the up or down inputs have remained high for the period given by hold time. For example, if hold time equals 2 seconds and repeat time equals 0.5 seconds, then if down remains high for 2 seconds, A out will decrement every 0.5 seconds until down goes low or until the lower limit is reached. If the feedback signal is defined, A out will adjust once and hold at the new value. There is a single precision parameter called increment, which is the amount the analog output will increment by. The lower limit defines the lower limit of the analog output and how low the analog output needs to go. For example, if you were doing a range of 0 to 100%, then the lower limit will be 0%. The upper limit defines the upper limit, which in our case would be set to 100%. The mute level defines the level, which signifies a mute. In this example, we will be using 0% as the mute. The mute does not latch in this logic symbol, so we will need to program it to latch by other means. Since it will only mute as long as the digital input called mute is high, we will need to latch the mute signal high whenever the end user wishes to mute the system. If we did not latch the mute signal, it would only mute for as long as the user is holding down the mute button. We will start by copying the volume up and down signals to the input of the analog increment. On the analog output, we will name it volume.level. This will represent the value of the volume. Next, we will set the increment. When the analog output changes, how much should it change? If we put 2% here, it would increment by 2% every time the repeat time activates. Hold time equals how long you would hold down the button in order to activate the analog increment. We will set this to 0.2 of a second because we want it to happen quickly. We used a leading 0 on the hold time parameter, but this is not a requirement. If we used a 0.1 second value, it would be the same value as entering 0.1 second. The leading 0 is best practice since it can be difficult to see the decimal point when adding fractions of a second into simple windows. Adding a leading 0 makes it easier to identify that fractions of a second are being used. For the lower limit, we will use 0%. The upper limit will be 100%. The mute level will be 0%. Next, we will program the mute, meaning we need to create logic that can latch the mute. Navigating to the memory folder, We will use a new logic symbol called a toggle. The speed key for toggle is just the word toggle. So we will highlight the volume folder, type in the word toggle, and press enter on the keyboard. We will open the toggle and discuss how it works by viewing the help file. The toggle has a digital input called clock and two optional inputs called set and reset. There is a digital output and an optional output called out star. The clock signal toggles the state of the out signal and the out star signal on the rising edge of the input. This means that every time the clock signal is activated, it will cycle between two outputs. Pressing it once activates it. Pressing it twice activates the out star. Pressing it the third time activates out, and so on. The two outputs have break before make behavior, so only one can be active at a time. The clock signal latches either the out or the out star signal high. This is the exact behavior that we want for our mute signal. There's an example of how to program a mute in the help file. We will take the volume mute button press and send it to the clock input of the toggle first. We are only required to program the out signal, which we will name volume.mute.feedback. This signal will go to the mute input of the analog increment. What about feedback? Since the output of the toggle is an accurate representation of whether or not the system is muted, we can take that same signal and put it on the left side, which is the feedback side of the smart object. The mute button will now light up if the system is muted. The last steps are connecting the analog output of the analog increment to the amplifier and to the volume feedback on the panel. For the feedback, we will connect the signal to the analog feedback join number 2. The amplifier is a DM-RMC200C, so we will place the analog signal on that. The first step should always be to open the help file and locate the correct place to land the signal, which is DAC output volume. The DAC out volume sets the volume level at both the audio outputs. Valid values range from 0D, which represents minus 80 dB, to 65535, which represents 0 dB. We will drag the volume.level signal to the DAC out volume on the DM-RMC200C.